Hello everyone, thanks for joining today. My goal is to share practical guides how to optimize your Databricks spans. We aren't just talking about cutting costs, we are talking about building system that gives the most value. To solve the cost problem, we need to first understand how the billing works. Databricks was dual billing model. Usually teams focused on DTU. These platforms usually focused on notebooks and jobs. But like the icebergs, biggest part of the hidden underwater. These are the cloud infrastructure cost, VM, storage, and networking. It's reality infrastructure costs 50 to 2% of your DTU bill. So total cost of ownership is 2 to 3 times of your Databricks invoice. Let's start with the biggest factor, is compute. Usually makes 70–80% of budget. Here is the strategy. Rightsizing, not just the default settings. You must match your VM types that workload usually needs. Workload types, move your production jobs, job compute. It must cheaper than the all-purpose compute used in development. Auto-termination. This is the best way to stop waste, not just your VM types or for all your workload types. Like a shutdown after 15 to 30 minutes inactivity, so you don't pay the idle cluster. And the spot instance, if your job can handle restarts, using spot instance, you can save 50% and the 19% of money. Let's look at the query engine Photon. Like the high-performance engine, but cost more per hour, you need to choose carefully. When you use it, Photon is great for big jobs that use lots of CPU, complex join, and fast analytics. When they avoid it, it's usually not worth the cost of for small ETL jobs. Jobs are waiting for data IO bound or pipeline that use a Photon code UDFs. You cannot fix your compute cost. Your cost is your storage messy. Organize your data well, directly lowers your compute usage. Automated maintenance, use a predictive optimization. Less the system automatically cleans up data based on your usage. Storage cleanups, regularly vacuum commands, delete old files. There's a small file problem. Use the optimize command, combine many small files in the large ones. And the modern partitioning. New tables use a liquid clustering. It replaces the older method and makes data organized, automatic, and flexible. We are seeing a big shift in serverless. This takes away from the managing infrastructure, start up very fast, usually 2 to 6 seconds. It also financial benefits, like no fees, no private links, better caching. It's very cost-effective BI workloads that's unpredictably and bursty. However, technology is not enough. You need the good rules to cost down, policies, tagging. Use cluster policies to stop people picking huge clusters and force them auto shutdown settings. Taggings, you must tag resources. If you don't tag, you can't see the spending money. Monitoring, use system tables, especially system billing usage, to see exactly what's happening in the account. So, see in the action, let's look at the real sample. Data engineering team has a critical daily job process, 1 terabyte of data. The job took over 2 hours, the kept missing 9 a.m. deadline. The team was under lots of pressure to fix it. Their first reaction was a brute force. Just added more power, double the cluster size, 60 to 30 nodes. Result was poor. Job only finished 20 minutes faster, but constantly cost nearly doubled. This proves a simple rule. Adding more resources to the bottleneck, it's like adding more cars to the traffic jam. It costs more, but doesn't solve the problem. They looked at the data on the Spark UI and found two problems. I/O bottleneck and system spends 99% of the time just listing files. This is the classical small file problem. CPU bottleneck. Even when it's reading data, CPU's usage only 30%. That's a standard engine could not use hardware efficiently. To fix this, they do two things, storage layer and the compute layer. Storage layer, they run optimize command to combine millions of small files in large blocks. This fixed the I/O problem. Compute layer, they turn on the Photon engine because of the Photon engine native C++ engine. It skips the slow parts at the JVM and use the full power of CPU. Final result was surprising. Real time, the jobs drops 125 minutes to just 25 minutes. Cost efficiency, even through Photon engine cost 50% more per hour. The job finished faster than the total, dropped to 70%. This shows the cheapest hour rate, not always the best choice. Total cost of ownership depends on the efficiency, not just the list price. Thank you for listening.